This video provides right triangle trigonometry definitions. But before we get to that, we want to talk about the definition of cofunctions. Given triangle ABC, where C is a right angle, it is noted that angles A and B are complementary and that sine of A is equal to cosine of B. Well, let's take a look at a triangle ABC here. Okay, so let's take a look at some side here, say the bottom side. If we're using A as our reference angle, we know that sine of A is going to be the opposite side over the hypotenuse. So our opposite side is CB, and our hypotenuse is going to be AB. So sine of A gives us this, I'm going to write CB over AB. Now our angle B down here, say we do cosine of that angle. Cosine is our x over y. It's our adjacent side over our hypotenuse. So cosine of B is going to be the x side, which is that side CB again, over our r side, our hypotenuse, which is AB. So you see, we get the exact same thing. Sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions as well. So here, when I've written out the 6 cofunction identities, I've paired them up vertically. So you'll see with sine and cosine, sine of A is equal to cosine of 90 minus A. All this 90 minus A just means the complementary angle. So then secant and cosecant, cofunctions. Cosecant of A equals secant of 90 minus A, while secant of A equals cosecant of 90 minus A, and tangent and cotangent follow that rule as well. So let's use the cofunction identities to find one solution to the equation cosine of theta equals sine of 2 theta. Anytime we're solving a trig equation, and we'll talk about this a lot more later in the course, we want our two sides of the equation to be in terms of the same trig function. So I'd like to either change cosine to sine or sine to cosine. I'm going to change the cosine of theta to sine. Our cofunction definition said that cosine of A is equal to sine of 90 minus A. So this cosine of theta I can replace with sine of 90 minus theta. And then our other side stays the same. Now that we have the same trig function on both sides, we can simply set the two arguments equal to each other and solve. This gives us 90 equals 3 theta, dividing both sides by 3. We get a final answer that theta is equal to 30 degrees. All right, now let's get to those right angle trig definitions. So consider this angle in standard position, and I've created a right triangle with it. The side of length y is called the opposite side to our angle A, or our angle theta. I kind of have it double labeled there. And the side of length x is called the adjacent side to angle A. So opposite means it's going to be across, and then the adjacent side is right next to the angle, so the adjacent side is right here. Now we're just going to take the 6 trig definitions that we already know and put new words to it. we know that sine of A is y over r. But we just said that side y is the opposite side, and we know that r is the hypotenuse to this right triangle here. So sine of A, which is equal to y over r, can also be thought of as opposite over hypotenuse. It's kind of like the same thing with slope, that sometimes we want to think of slope as y2 minus y1 over x2 minus x1, and other times we want to think of slope as rise over run. It just means the same thing, but depending on the context, we want to think about it slightly differently. That's the same thing that's happening here. So sine of A is y over r, or opposite over hypotenuse. Cosine of A equals x over r, or adjacent over hypotenuse. Tangent of A equals y over x, or opposite over adjacent. Those are really the only three that I know, and then I just know that the other three are the reciprocal. So cosecant of A is r over y, or hypotenuse over opposite. Secant of A is r over x, or the hypotenuse over the adjacent side, and cotangent of A is equal to x over y, our adjacent side, divided by our opposite side. There's a silly word that lots of people use to help us remember our trig functions. So, SOHCAHTOA. And this gives us the definition for the first three here. Sine is opposite over hypotenuse, so that gives us the SO. Cosine is adjacent over hypotenuse, that's our CA, and then tangent is opposite over adjacent, giving us our TOA. SOHCAHTOA is something I use all the time. I would really recommend remembering that to help you remember your trig definitions.